So if you're struggling with the atomic radii, it might be useful first to go to the data booklet and just see what the answer is as far as the conclusion, that the atomic radii, which are these ones, they decrease across a period and they increase if you look at these numbers here. All right, but you're only going to get 1 mark for stating or maybe no marks at all. It's about the explanation that's going to be what's on your mark scheme. So first of all, the definition is a little strange, half the distance between the nuclei of 2 atoms, and that's because that's how it's experimentally determined. They get X-ray diffraction through a crystal, and so they can see the points, so they take half that point, that's the radius. They can also visualize this too with electron microscopy, and so they experimentally determine what the size of these atoms are. Okay, most significant for our understanding is to realize that the radii is like 10,000 times smaller, so it's mostly space. So the nucleus is about the size of a tennis ball, and then the atom's about the size of the Earth. So they're enormous distances, and the significance of that is Coulomb's law. So it doesn't matter if this is positive or negative, you can see that the radius squared, that the size will decrease the force, but it's exponential. So the distance, the size of the positive or negative charge is far more important than the actual size of the positive or negative charge, just like every other force, like magnetism or gravity. So distance is more important than size. So the atom's mostly nothing. So why can't you put your hand through a wall? The same way you can't put your hand through a fan. The electrons are moving quite quickly and will cause repulsion, which is why if you look at some super fluids at very cold temperatures, I forget the term now, but if you look those up, you can see that liquid will actually crawl up liquids or go through cups once you get down to 273 minus 273 or 0 Kelvin. Once you get those electrons to stop, you can get some very strange things happen. So moving on, hopefully you've done this experiment in junior science somewhere. This is just to experimentally prove the exponential. You'll get a curve, and so that proves the law, so we know that the law works. Okay, so the key terms, most of your answers, every answer will have one of these terms. Sometimes you'll have all 3. So the most important thing is just everything that's positive is attracted to negative. So obviously nuclear charge, the number of protons, and then distance, so the size, how many shells there are, so how far away it is. But you also have the electrons blocking the positive to the negative attraction here, and you also have them repelling each other as well. So that will alter how these outer electrons will react in chemical and physical reactions. So remember those terms and understand what those terms are. And so here we go. I've tried to be a bit more explicit because I found for those that are really struggling, you might want to have to resort to memorizing, but understanding is always better, and it's always, I never quite say it the same way twice. So if you're a weaker student, it may be better off to start with memorizing this stuff. I will never say the same thing twice when I'm explaining this. So you need to get an understanding to the point where you can paraphrase this. But the weakest students I've found never quite get this, and the strongest students can. So if you're a weaker student, try and memorize it and see how that goes. That's the worst way to go about things, all right? So always try not to memorize. Always try to understand it and see if you can do it based on understanding. Okay, so the most important one, this for the going down, is that you've got additional electron shells, which may be enough for some mark schemes, but don't risk it. I've gone into detail in these explanations here. And so the nuclear charge is also increasing, but because distance is not as important as size, the effect of those protons pulling on the electrons to change the size of the atoms won't be as effective, as well as the electron shielding is blocking that positive to negative attraction between the valence electrons and the nuclear charge, and the electron shielding also is repelling those electrons as well. Okay, so for all of those reasons, the valence shell electrons are further away from the nucleus, so the atomic radius increases. Okay, moving on to the next one, and I'm not sure if you've done this yet, atomic, but once you get to atomic and you're answering specific questions, make sure you say exactly which orbitals they are. So the three, energy 3 versus 4 or whatever, or maybe down to the level of the SPDFs as well, and which elements they are. Get very specific. Okay, so for the periodic trends, this one's a little simpler. They both, as you go across a period, I'll be using period 3 as much as I can, there's always the same distance of the nucleus to the valence shell, because they're all in the same valence shell. And also, they have the same amount of electron shielding. So the only difference is that the nuclear charge increases. And so if the nuclear charge increases, the attraction between the nucleus and the valence shell electrons increases, and so the electrons are pulled closer to the nucleus. So as you go across the period, the atomic radius actually decreases.